Good morning, children. Welcome back to science class. Now I'm going to teach you lesson 5 electricity. This is belongs to physics. Electricity. So whatever the thing, atoms are the main particles. It is a good morning, children. Welcome back to our science class. Now I'm going to teach you lesson 5 electricity. This lesson has belonged to physics. This is our video session 30. Atoms. Atoms are the smallest particle, take part in all the matters, solid, liquid and gaseous matters. Atoms have three main inner particles. They are proton, neutron and electron. For the conduction of electricity, proton and electrons are very important because proton carries a positive charge and electron carries a negative charge. So these two are very important for the conduction of electricity as well as the production of electricity. Charges. We have two types of charges. In the given picture you can see the first set of charges positive, plus denotes positive, and then second set is denoting negative, minus, and then the third you can see plus and minus, so opposite charges. In the first two charges, the same charges, when comes together they can repel each other like a magnet. How the same poles, the north pole cannot attract towards it because of the same poles cannot attract, they can repel. Likewise here also the positive charges cannot be attract towards it. In the same manner the negative charges also cannot attract it, they also repel with each other. But the final thing, one positive, one negative, that is opposite charges. Always opposite charges attracting towards it. That's why the electricity also, these positive and negative charges together, they are conducting electricity. How the transfer of charges, that is the electricity. Here charges taking place. Conduction. Conduction is nothing but of from one place to another place it is transferring. In our house also we have electrical devices. Wherever the places when we switch on the light or whatever the electrical items, immediately it is running because of what? The transfer, that conduction of electricity taking place. Here also in the rod and then a ball, metal ball, one is a negative charge. When this negative charge touches the ball, what is happening? That negative charge is conducted by the metal because electrons transfer to the object making in the same charge. When the metals have the same charge, when it is touches the other metal, it is transferring the charge. So this is called conduction. From one place to other place it is moving. So transfer of charges based on the conduction is taking place here. Transfer by friction, transfer by conduction, and then transfer by induction. These are the three methods when we transfer a charge from one place to another place. That is called conduction. Transfer of electricity by the friction, conduction, and then induction. Next, transfer by friction. Friction is nothing but of the force acting on two individual bodies. Here see, when the PVC pipe is attracting the piece of paper on the floor, because of what? The friction. When we rub the materials very harshly, it can have a charge on it. So based on the friction it creates a charge. That's why the PVC pipe is attracting the paper. So here the charges has been conducted because of the friction. Next, transfer by conduction. Already I told you transfer by conduction. Here the pipe is having a positive charge and then the ball contains a positive charge. So when these objects are moving close together, what is happening? The charge is negative. So both are having a positive charge. When these two objects comes near closer to that, then the charges has been changed. So negative induction. Because of what? Already I told you, same charges can repel each other. They cannot attract it. So that the negative charge has been inducing here. Next, charging by conduction involves the contact of charged object to a neutral object. Neutral means it doesn't carry any charge. So when it is touches the neutral charge object, it conducts electricity. In contrast to induction, where the charge is brought and then near but never contact to the object. Even if it is not contacting the object, then also it is conducting electricity. It is nothing but of what? The physical connection. For example, a person, when it was the shock was happening to him, when the other person touches that person also can feel a electric shock. Because of what? The electricity is conducted by the means of that person. So this is the thing happening here. The neutral object, when it is touches the particular object, the charge is flowing on. This object also carrying a charge. Transfer by induction. So what is the meaning of induction? Here you can see one upper, we have a one object, it has a negative charge, and then the device itself, we have a central rod, it carries a positive charge, but below it has a negative charge. Because of what? When the charged particle close near to the positive charge, the positive charge is attracting. We already know opposite charges can attract towards it. So while it is attracting, and then what is happening? On the bottom it separates the negative charge. On the top it is attracting the negative charge. Then while it is transferring the charges, while going down it is removing the negative charge. This is the term, we can call it as a induction. So opposite charges attracting towards it, and then while going down it is discharging a electron. So induction taking place, the transferring of electron. This method is known as induction. In the induction process, a charged object is brought near but not touched. So they are not touching each other, only it comes closer to the object. Neutral conducting object. The presence of a charged object near a neutral conduct will force electrons within the conductor to move. So when the object is goes near to that, what is happening? The electrons are attracted by the positive charge particle. Then finally the bottom, it doesn't carry any charge. Automatically the neutral object can discharge a negative charge. Here in this picture, how the flow of charge. So through the wire also the electron flow will be like that. See, in this end, that is the left end, we have a negative charge, right end we have a positive charge. So through that electrons are flowing. The electron flowing only we are saying as a flowing of current. So flow of current or flow of charge. Because why we are saying as a charge? One is a positive, another one is a negative. So obviously we can call it as a charge. These charge only, commonly we can call it as a electricity. Electric current, yes, electric current is a flow of charges, positive and negative charges. The thing is charge, and there can be many different objects that carry the charge. Yes, so different objects can carry the charges with the help of the wires. The charge originates in the circuit itself. Yes, the electric circuit itself, it has a charge. When we switch on the light or electric devices, immediately the charge is conducted, so the devices are working. That is what it is to be the electrical conductor, to have a charge that can move when the conductor is connected into a complete circuit. So when the conductor is connected a complete circuit, then only the flow of charge is taking place. Here we have an electroscope. It is a device, scientific instrument used to know the flow of charge. So the same thing what we did for induction, here also when we are touching the positive rod to that, it has a negative charge. So what will happen? It discharge the negative charge at the bottom. So it is called a induction. With the electroscope, we can easily know the flow of charge. So this is a scientific device. It is useful to know the conduction of electricity as well as the transfer of electrons. Then electroscope is a scientific instrument. The electric charge on a body, the charge by the movement of a test object due to the Coulomb electrostatic force on it, the amount of charge of an object is proportional to its voltage. So the amount of charge based on the how much voltage it has. So based on the voltage, so all the devices when you can observe it, it is mentioned the voltage. So what is the power consuming for that particular electrical device? They have mentioned in the object itself. That is called voltage. Based on the voltage only, it can consume electricity. Next, we have a gold leaf electroscope. This gold leaf electroscope was invented by British scientist named Abraham Bennett. He used gold and silver. Inside we have a gold and then top also gold. But the body of the instrument was made by silver. So it was placed at the glass jar. A gold leaf electroscope is a simple device. It is used to identify the electric charge present in a body. It is based on the repulsion and then attraction. We already know same charges, when they come close together, they can repulse with each other, but the opposite charges can attract each other. Based on that, we can easily find out what charge is acting on the particular object, and then it is charged or not. So these are the things with the help of the gold leaf electroscope we can easily find out. And then the gold leaf electroscope is used to detect, measure and find the nature of a charge. So what type of charge is it? So when the same charges are there, means what will happen? It repulses. So we can identify the same charge. So what type of charge? Okay, then it consists of two thin strips of gold attached to a metal rod which is suspended inside a glass jar. They then diverge, indicating the presence of charge. So what is happening? Not only find out the charge is there or not with the help of the gold leaf. When the charges are there, means it is moving away. Two leaves are inside it. It is moving away. So we can easily find out the charges present in the jar. Assignment for this class. What is a charge? What are the ways to transfer of charges? What is the electroscope? Explain the working of a gold leaf electroscope. Thank you, children. Have a wonderful day.